So today we will finish up our syllabus and have your Viva in the rest classes. अब बच्चे कितने हैं जितने भी हमारी मेरे ख्याल से we have around 7 to 8 classes or more than that. So we will have Viva assignment whatever you are giving as a presentation, and we will also today I have shared a question paper, last year question paper, which is of physical science, but the syllabus is same. So I have shared the question paper which was in OB mode. मेरे ख्याल से दिसंबर का पेपर होगा शायद, तो वो वाला मैंने शेयर किया है और वो क्लास में थोड़ा सा डिस्कस कर लेंगे व्हाट काइंड ऑफ क्वेश्चंस वी आर getting in the examination. And I have 2-3 more question papers, so we will discuss those also. Okay. So today I just finish off this topic, which is last topic, that is colored quark. What do you mean by color? And what are the mechanism that we have to follow when we are discussing the color of a quark? Okay. So let me just introduce. Previously also I have many times I've said that why we require the color kind of character in this quark model, because they are being kept in a very small space, and we have the spin, we have the space, and we have the flavor of the quark, that is up, down, and other quark is also there. But even if you have particles which is having all the quark, they are same kind of flavor. For example, you have UUU, which is D++, and you have omega, which is triple S, and you have the D minus, which is triple this D. So because of these kind of particles, and they are very small particles, so we cannot have a similar kind of particle because these are fermions. They have half integral spin. So we cannot keep them in a very small dimension. So that is not a possibility. So we have to define a new kind of, you can say, character or new kind of quantum number to these quark. And all of the mechanism has to be understood in that way. So if you introduce a new quantity, then your whatever the experiment or whatever the decay or whatever the thing you are doing with these quark, that should be followed. Means you have to give a mathematical formulation, and that mathematical formulation should be means it should be consistent with your already existing results. So that is why we have to understand what do you mean by these colors, and how many colors are there, and how they are interacting with each other, and if any quark emits a gluon, then what happens to it, means how its color is changed or how it will do the things, and so that we have to discuss. Okay, let me just write it some points. Okay, so colored quark and gluons. This is G actually. So we have seen that D minus, which is having all the DD quark, which and D plus plus is having all the UU quark, and we have omega, which is having all the 3 quark. They are similar. It means all the flavor is same. So if you write the wave function for these quarks, so this will be spin. They have their individual spin, and obviously all the quark have spin half. So you have to write the spin half kind of wave function, which is concerned with the spin. Then you have a space, means how much, what kind of orbit they are following. So what kind of space they are occupying. So that you have to write the wave function concerned with the space. And then the third wave function, which is actually the multiplication of all these things, will be the total wave function of your quark in any particular space and time, whatever you want to write. If you have a potential, you can reduce these wave function also. Then you have flavor. So flavor is actually concerned with something which is U, D, up, bottom, sorry, up, down, strange, bottom, top, and we have one more, that is UD, strange and bottom, truthness, and there is one more. UD, bottom, top, and strange, and there is one more, truth, I think. Yes, truth. So that is T, but we have to use a different symbol. So these different kind of flavor that is concerned with this particular wave function. Space, we already know it is occupying certain space because these are fermions, and the spin, which is actually the concern with the spin of the quark. So if you write these three wave function for these particles and you try to find the total wave function, so they will be similar. Means all the three quark will have all the quantum number same, and that is not possible if they are fermions. So they cannot occupy the same space and at the same time. So you have to distinguish. They are distinguishable particle. They're not indistinguishable. For example, boson are indistinguishable. Means in the same state you can keep several number of bosons. Within the same state you can keep several number of bosons. But the fermions normally we have in one state we can keep two because of spin half रख सकते हो, दूसरा spin आपका plus half हो सकता है, minus half, means parallel and anti-parallel. So you can keep only two, you cannot keep the third one, so that is not a possibility. So we have to introduce a new kind of wave function so that this wave function become antisymmetric. So this wave function become antisymmetric, means they have certain different kind of wave function. So we have to introduce a new wave function, and this new term is actually concerned with the color of the quark. So it's just a new kind of wave function, and we have to design our whole of the thing. Means what kind of decay you are discussing, what kind of things you are discussing with these particles, you have to design according to that, and your model should fit that. ऐसा नहीं होना चाहिए कि आपने डिफाइन तो कर दिया, चलो कलर होते हैं, और कलर जब इंट्रोड्यूस किया उसमें कुछ मैथमेटिकल रिलेशन बनाए और फिर कोई डिके प्रोसेस वी आर चेकिंग, and that decay process does not follow your designed mathematical tool. So that is not possible. So we have to design that. So this new term which is given as color to the quark. So the quark comes not only in flavor but they also come in color. तो एक flavor भी है उसके पास और दूसरा एक और property है which is color. So how many colors are defined for the quark? So first one is red. That is doesn't mean कि वो red होता है, ये मत समझ लेना कि वो red होता है. कई बार बच्चों को लगता है कि हाँ शायद red color का quark हो. No, this is not something like red color. It is the name is given as red. So we have a symbol R, obviously. Then we have blue. So that is blue, and we have green, which is very common, you know, RBG. So when you mix the RBG, you get a colorless value. So that is why these color has been used. So we can see something like this one. So we have a red color quark, and we can have a blue color quark, and we can have a green. So these are the different quark, which is, for example, if you want to write this particular, means now if you want to write what is the composition of delta plus plus, then you can easily write something like that. That is, you have a U which is of red color, and you have another U which is of blue color, and you have another U which is of green color. So now you can see that all the three are having certain difference, certain quantum number is different for all the three, and you can keep them in a very small space. So that is a possibility. When you define a new kind of property or new kind of quantum number, then you have a possibility that you can fit them in a certain space, and that space is very small. That is size of you can say proton or neutron. So within a fraction of Fermi, you can keep these three particles because they have something which is different. They're distinguishable. This is what we have to think. They have to be distinguishable. We have to identify कि ये अलग है, ये अलग है, और ये अलग है. So we have to introduce the color, because all the three things which is already there for the wave function, that is not giving a better antisymmetric wave function. So they are symmetric, means for all the three U or all the three D or all the three S, they're same. So introducing these colors give you means it just again prevail your Pauli exclusion principle. Now, if you have the color, then there must be anti-color also. If you are having a color, so there must be anti-color also. So because quark exists in the particle form or in an anti-particle also. So we have the anti-quark also. So first one is anti-red. So that is C, you can say cyan. Cyan is the color which is, I will use this particular this one. So this is your anti-red color, which is cyan. Then you have the anti-blue, and that anti-blue is you can say this M, that is magenta. So magenta is this one. Okay, now we have the third one, which is anti-green, and that is used as Y, which is yellow. So these are the, okay, yellow is not seen. Yes, yellow. So these are the fancy quark we have: red, blue, green, and cyan, magenta, and yellow. These are quark and these are anti-quark. So these are, you can say, anti-quark, and these are normal quark. So you have to remember these things. So whenever you write a composition of, say for example, if you want to write a composition of this proton, कि सर प्रोटॉन का कॉम्पोजिशन अब क्या होगा, उसका तो U U D होता है, तो what we have to write. So what you have to always think that when you are mixing these color, your result should be something which is colorless. So if you mix these two color, means red and cyan, so that will be a colorless. You're mixing a red and anti-red, so that is a colorless. When you're mixing blue and anti-blue, so that is again a colorless quantity. When you're mixing green and anti-green, so again that become a colorless, because you're mixing green and anti-green, so they will mix up with something like a zero color. So you can make a combination of red and another red, which is anti-red. You can make a combination of blue and magenta. You can make a combination of green and anti-green, that is yellow. Even you can make a combination of all the three. दो के combination में तो हमारे पास क्या हो गया, mesons बन गया. And when you make a combination with three of these particles, which is can be a quark and can be all the are anti-quark, so that will become a baryon kind of thing. So you can have a RBG. So for example, if I ask you कि प्रोटॉन के लिए आपने U, U और D लिखा था, अब इसको ये तो सिर्फ हमने फ्लेवर के फॉर्म में लिखा कि it has two flavor of up quark and one flavor of down quark. So if I ask you to write in terms of color, means you had to include the color. So you will write UR, UB, and DG, so that they should be a colorless quantity. So as a particle, quark is having a color, but when the quark forms certain composition, or if it is being forming any particle, so that particle is always colorless. So that you have to think, means all the mathematical things you have to understand in that way. So any reaction, any decay process should be understood in this kind of way. It means you cannot only discuss with the flavor, but you have to include the color also, and the things become more complicated. Okay, so what the color do, why we introduce the color? So color, I have already said you, it can be introduced because you need to prevail the Pauli exclusion principle. So what it is doing actually, why we are introducing and what it is doing. It is the same thing. It has a similar kind of behavior as we know about the charge. So sometimes it is called as color charge also. तो इसको कई बार नाम color सिर्फ नहीं देते हैं, लिखते हैं color charged. So it is similar kind of Coulomb interaction. Coulomb interaction में we have only two flavors. We have plus and minus. और कोई फ्लेवर पॉसिबल नहीं है, बट हियर वी हैव अ 6 फ्लेवर्स, सिक्स डिफरेंट कलर। तो आपके पास कूलम्स में आपके पास सिर्फ दो ही है, प्लस और माइनस है, और कोई थर्ड काइंड ऑफ चार्ज इज नॉट देयर, but here we have 3 and their anti is also existing, so that is total of 6 different color we are having, and we can make several possible combination of these different colors, and we can get the particles. Now once you write these colors, then you can write the wave function, that is something like introducing a new wave function which is color wave function. ओके, तो आपके पास ये वेव फंक्शन तो पहले से ही है, जो कि कुछ डिफरेंशियल इक्वेशंस के फॉर्म में, कुछ एक्सपोनेंशियल है, कुछ साइनसोइडल फंक्शन है, तो it is already there. But this new function which is concerned with the color, so you can write that wave function which is always written in this form, that is 1 upon, and it should be in such a way that even if these three are having the same kind of you can say function, but this will introduce something which is going to make this total wave function as an antisymmetric wave function. So we have to write the correct combination of color, and when we change the position of color, means if you so let me first write the wave function, then we will see if we change the position, then the wave function must become antisymmetric. For example, there are two electrons in an orbit, so those two electrons are not same electrons, they have to be different. This is what we always think. The two electrons in an orbit, they have to be different even though everything is same. So what we say कि spin एक का up है और एक का down है, किसी भी सेंस में, किसी के रिस्पेक्ट में, मे बी न्यूक्लियस के रिस्पेक्ट में होगा, या किसी भी सेंस में रिस्पेक्ट में, ये व्हेन यू आर डूइंग द एक्सपेरिमेंट के अलोंग, वन इज पैरेलल, वन इज एंटी पैरेलल. इट मींस we when electron is in an orbit, we have the spin wave function which actually distinguish between the quantum numbers. उसका n, l और m तो सेम होता है, but s हमारा प्लस हाफ और माइनस हाफ हो जाता है, तो we can say the four set of quantum numbers are different. So this is what we have to think, means if you have a proton, there are two u, and these u, if they change their position in the orbit, if there is an arrangement, you can say structure within the proton also, and if they change their position, they have to be different. This u must have a different wave function, and this u must have a different wave function, so that they can be distinguishable. So they can be distinguishable. So let me write this wave function which is concerned with the color. So it is RGB. We are not writing the flavor, we just write the color. And BRG and plus GBR. You don't have to remember this. This is just for your understanding why this is written in this way. And we will see one example that it give me a this antisymmetric wave function. So this is a color wave function, you can say. So these are actually concerned with the color. We have to write in the flavor form also, but हम इसको सिर्फ color के form में लिख रहे हैं. Normally इसी sense में लिखा जाता है. And if you change the position of, means if you change R to G and G to R, then your wave function must be negative of this one. The total wave function आएगा ना, that should be negative of this existing wave function. If you shift, means what you're doing actually, you're trying to shift the position of two different color of quarks. क्वार्क को ही आप उठा करके दूसरे पॉइंट पे, उस क्वार्क को उठा के दूसरे पॉइंट पे ले आ रहे हो. अगर आपके पास कोई डिफरेंस नहीं आता है, if you don't get any difference, then you will say there is no color. And if you get a difference, or you should get the difference, you have to write this function in such a way that if you change the color of two different quark, so you have a different wave function. तो आपके पास एक अंडरस्टैंडिंग होनी चाहिए, दोनों डिस्टिंग्विशेबल है. अगर मैं इसको इस पर्टिकुलर u को मैं r कह रहा हूँ, इसको मैं b कह रहा हूँ, और सडनली मैंने बोला कि नहीं ये मेरा b है और ये मेरा r है, और इट इज नॉट मेकिंग एनी डिफरेंस. तो व्हाट आई एम सेइंग कि दे आर इंटररिलेटेड, मींस दिस इज नॉट red color, this is actually blue color also, and this is not blue color, this is also red color. So there is no difference between these two u. But yes, what you have to do, when you change the color of these two different quark, you should get a different wave function, and that should be a negative of that one. So आपने जब shifting की तो आपने negative of that one you should get. So we can check that. So do we are getting so let me write this new as new wave function, which is concerned with the interchange of these colors. So let us write this one, and do we are getting anything, and we have to write in this way so that we should get. हम mathematically हम tools ऐसे ही बनाते हैं जो कि हमारे result को justify करें. So let us change this. So first one is this will become G and G will become R. तो हमें सिर्फ इतना ध्यान रखना है, B तो change नहीं होगा, बाकी R और G change होते रहेंगे. तो B, this will become G and this will become R, and plus G will become R, B is as it is, and R will become G, and minus this will become G, B, and R minus B is as it is, and G is R, and G, and minus G will become R, and B, sorry, not B, so I have to write G and B. So they are not same है दोनों. बहुत सारे मैच कर रहे होंगे, बहुत सारे नंबर. आर जी बी यहाँ पे भी है, आर जी बी यहाँ पे भी है, बी आर जी यहाँ पे भी है, बी आर जी यहाँ पे भी है, जी बी आर यहाँ पे भी है, जी बी आर यहाँ पे, आर बी जी यहाँ पे भी है, आर बी जी यहाँ पे भी है, पी जी आर यहाँ पे भी है और यहाँ पे जी आर बी यहाँ पे भी है. बट क्या डिफरेंस है? If you write, this will be the same term here. So you have to take this negative sign. Means this, if you do the shifting, the new wave function will be minus of your whatever the color wave function you have to. आपने जो भी कलर वेव फंक्शन आपके पार्टिकल का होगा, जब भी आप पोजीशन शिफ्ट करोगे, ये आर और जी के लिए था, यू कैन डू विद द जी बी आल्सो एंड जी आल्सो. So if you try to shift these things, so they should appear as a different particle, and that has to be there. अगर वो नहीं होगा तो कलर इंट्रोड्यूस करने का कोई मीनिंग नहीं. Is it okay what we are discussing? Obviously this is very you can say abstract kind of thing, but still just ये मैं example ले लेता हूँ. This is an orbit and you have a electron, two electrons, and they have up and down spin, and if you change the position, your wave function should be different, your result should be different. If you change the position of these two electron, and if nothing changes, then there is nothing kind of a spin kind of thing in the electrons, or they are not having any spin kind of character. अगर ये मैं शिफ्ट करता हूँ पोजीशन और कुछ गड़बड़ होता है, फॉर एग्जांपल इसको इस तरीके से नहीं समझना, इसको इस तरीके से समझना. यू हैव ऑलरेडी डन कि फिलिंग कैसे करते हैं. तो फिलिंग अगर 3 ऑर्बिट है तो यू जस्ट फिलिंग विद अप अप अप, and you have extra electron, then you start with the down down down. So this is what you are doing. पहले अप से फिल करते हो, फिर डाउन से करते हो. अगर अप और डाउन का कोई सेंस ही नहीं होता स्पिन का, तो कैसे भी फिल कर दो, क्या फर्क पड़ता है? There is no difference. You have to first fill with the up spin, then you have to fill with the down spin. This is what you have to remember. So ये is it clear to you? The things what we are discussing, is it clear to you? नहीं तो और easy में जाएंगे, उतना ज़्यादा उसमें नहीं जाएंगे, टफ में. बोलो, is it clear to you or not?
Yes, sir.
Yes, sir.
Okay, so this color wave function, actually this very long kind of term, which is written for the baryon. When we write for the mesons, mesons color wave function is, because mesons have only two quark, which is one is quark and one is anti-quark. So that is 1 by √3, and we have this anti plus G and G anti and plus B and B anti. So they're having less kind of term, you can say. And if you shift the position again, you get the different kind of thing. So that you have to remember. So color charge or color in the quark is similar as we know charge in a particle, or any you can say electrostatic or electromagnetic particle, you can say. And when you have the electromagnetic interaction, the photons are exchanged between the two charges. This is what we know already, that if you have a proton, if you have electron, or if you have a two electrons or two protons, they are exchanging virtual photons to do the interaction. In the same sense, when you have these and you also remember that these photons which is being exchanged, they don't have charge. हम जब एक positive charge है और एक negative charge है, and if virtual photon is being exchanged between these, so this particular is not having any charge. This we already know. इसमें तो कोई doubt नहीं है. This is always a zero charge. इसका charge क्या होता है? Zero होता है. इसका charge तो नहीं होता ना कभी. जो photons होते हैं, they are always चार्जलेस पार्टिकल है या नहीं है?
यस सर।
हाँ, ये इसमें भी डाउट है कि नहीं ऐसा तो नहीं होता, शायद कुछ चार्ज भी होते हैं। तो सिमिलरली व्हेन यू हैव कलर क्वार्क एंड ग्लूऑन्स को ऐसे हम शो करते हैं स्प्रिंग के फॉर्म में. So when the gluon is exchanged, they are not shown as a wave, but they are shown as a spring kind of thing, because that is something which is relating that if you stretch the spring, this force is stronger, and if you press the spring, the force will make them out. So repulsive or attractive force दोनों का एक meaning आता है. So we cannot put like this. So we have to put in the form of spring. So that is why. So when the gluon is exchanged, the gluon should be what? If you're doing an interaction between two color quark which have certain color, then what a gluon should have? क्या होना चाहिए gluon के पास? भाई ऊपर मैंने एग्जांपल दिया, इसी को एनालॉगी समझ के इसको बताओ कि क्या है. इसके एनालॉगस में ये प्लस माइनस है, दो डिफरेंट चार्जेस हैं, एंड जो एक्सचेंज पार्टिकल है जिसको हम वर्चुअल पार्टिकल कहते हैं, दे डोंट हैव चार्ज. So if you have a two different, if you have interaction between two different color quark, then what should be this one? This should be ग्लूऑन का क्या होना चाहिए? कलर होना चाहिए, नहीं होना चाहिए? चार्जेस के बीच में इंटरेक्शन है, वो चार्जलेस पार्टिकल है. कलर के बीच में इंटरेक्शन है, तो पार्टिकल क्या होना चाहिए? हम्म कलर होना चाहिए, नहीं होना चाहिए? Should we have the color or we should have the colorless? बताओ, फिर इसके आगे हम ग्लूऑन्स पे जाएंगे और फिर एक इंटरेक्शन भी चेक
कलर।
करें. कलर होना चाहिए. क्यों कलर होना चाहिए? भी देखो, दो चार्जेस हैं, and if you have certain charges, the interacting particle is not charged part. It doesn't have charge. It is a chargeless particle. Similarly, if you have color kind of quantity, so when the things means when the interaction is happening between two colors, so the exchange particle should be colorless particle. It
फिर एंटी कलर
means
में सर क्या होगा?
क्या?
कलर और एंटी कलर के बीच में।
कलर और एंटी कलर में भी हो जाएगा, कोई दिक्कत नहीं. अभी हम लिखेंगे उसे कैसे लिखते, वी विल सी दैट. हमें हमें मैथमेटिकली देखना है कि सारी चीजें सही होती कि नहीं होती है. कलर और एंटी कलर के बीच में भी होगा, और वो देखेंगे कि कैसा होगा. वी विल राइट दैट आल्सो. तो gluon must be something which is kind of colorless, but it carry color. Means it carry color, and one is always a color and one is anti color. तो जो gluon होता है हमेशा दो मिक्सचर होते हैं, बिकॉज यहाँ पे तो हमारे पास दो ही चार्ज हैं, प्लस और माइनस है, तो वी हैव अ चार्जलेस. बट दिस इज समथिंग व्हिच इज, यू कैन से कलरलेस, बट इट कैरी टू डिफरेंट कलर. वन इज ऑलवेज अ कलर एंड वन इज ऑलवेज अ एंटी कलर. तो ग्लूऑन जब भी बना होगा ना, अब नाउ वी विल राइट द, बिकॉज वी हैव हाउ मेनी quark, we have six different, three are normal quark and three are anti quark. So we can make a gluon by mixing up these two different quark, something like that. So जो gluon भी है वो, that is it is not exactly a state of quark, but it always carry a color and a anti color. पॉसिबल है कि अगर वो रेड रेड को कैरी कर रहा है, मींस जब भी वो रेड रेड को कैरी करेगा, मींस कलरलेस, एग्जैक्टली कलरलेस नहीं है, बट इट शुड बी अ कलर एंड एंटी कलर कॉम्बिनेशन. एग्जैक्टली इसको कलरलेस ना कह के वी शुड राइट एज अ color and anti-color combination. Gluon will must be a color and anti-color combination. When we see this three different quark, and we see these three different anti-quark with different colors, so we can make a combination. Means gluon must be, how many gluons it can be possible? Red can have a combination with these three anti-color. Blue can have with these three anti-color, and green can have with this three anti-color. So total, how many possibilities are there? So how many gluons we can have? We can have red, anti-red. We can have red and blue, we can have red and green. Then we can have blue with anti-red, and blue with anti-blue, and blue with anti-green, and we can have green with anti-red, and green with blue, and we have green with anti-green. Perfectly, these three are exactly colorless, you can say. But they can carry certain color also. Means this is a not exactly a colorless, you can say, but this is a combination of anti and color and anti-color, because there is more possibility. In this we have only two possibility, but here we have more possibilities. So these three gluons are exactly colorless, but they can carry certain color. When you mix them, they will have certain color. So out of these nine combinations, uh, these three which is exactly a colorless, so we have something which is called as combination of these three different colorless particles, because they exactly carry certain amount of color. ये तीनों छह को तो अलग कर दो, यानी छह तो exist कर रहे हैं, we have six, and out of these three, they don't exist in a very individual way, but they form in a something like a mixed up kind of system, or mixed up kind of wave function. So we have three different possibility of these three different combination. So I just write the or we can leave that, मेरे ख्याल से वो फिर equations ही हो जाएंगे ज्यादा. तो इनके three possible combination है according to your means these kind of symmetric and anti-symmetric wave function that has to be formed. So after these three combination of these three color, they have three different combinations. Just let me write. One by two means one by root two, r and r bar, and minus g and g bar. This is one kind of combination of these gluons. Then we have six and R, R bar, and plus G, G bar, that is red and green, and minus 2, B and B bar. And we have 1 upon root 3 and combination of all the three. That is R and R bar, plus G and G bar, and plus B and B bar. Normally, this is not possible. Only these two are actually carrying the color. They can carry color from one quark to other quark. So these two exist, means these are verified. Actually, these kind of interactions are verified with the exchange of gluons, but this is not verified. So this is not possible. So we have only six, which is individually these quark, and plus the two which is concerned with these two kind of combination. So we total have only 8 possibilities. 9 तो हमारे पास possible selections थे, because we have 6 color and 6 एंटी कलर, तो इनके 9 पॉसिबिलिटी थे, बट 9 में से भी हमारे पास तीनों कलरलेस क्वांटिटी हैं. वी हैव टू मेक देम कॉम्बिनेशन इन सच अ वे, एंड आफ्टर दैट only these two are possible. This is not possible because they don't actually change the color of the quark. So how the things happens, for example, if I uh, write, for example, this is the reaction pi plus and plus p, which is means meson is bombarding a proton, then you can get pi 0 and plus a delta plus plus particle. So let us check this in terms of quark, how these things are happening. Means if you write the flavor, or you can write the color form also. I will show you the color kind of interaction. Flavor to बहुत easy है, it is very easy to write, but color interaction is very difficult to write. Means you have to there is so many colors and so many gluons it being exchanged for a one reaction. एक reaction में flavor का तो sense बहुत easy है. We can easily check that. That is, for example, if pi, you are saying pi is made up of what? अगर check करो, पीछे हमने discuss किया था. Let me write for U and D. This is for proton. So proton is made up of these things, these three different quark. I'm not writing the color. I'm not writing the color. I'm just writing the flavor only. And the pi is made up of D bar and U. चेक करना, पीछे होगा शायद कहीं पे, हमने जब ऑक्टेट बनाया था तो उसमें मेंशन होगा इसका क्या कॉम्पोजिशन है. एंड एट द एंड व्हाट यू आर गेटिंग zero charge meson, which is a pi meson, and you are getting a delta plus. Delta plus is U and U. All the three are up quark only, and this meson is U bar and U. So this is at the end of the reaction, which is a delta plus plus particle, and this is actually a pi zero particle. So how the things are happening? यहाँ पे हमारे पास दो U हैं, मतलब टोटल 3 U है, यहाँ पे हमारे पास टोटल 4 U हो गए, यहाँ पे हमारे पास एक D भी था, यहाँ पे हमारे पास एक यहाँ पे कोई भी D नहीं है, we have D bar also and this U bar also. So what is happening, there is no means there is no change of flavor of this particular quark. So U become U only in this particular particle. This is all, this is just a rearrangement, and this is also there. So there is no big interaction is happening for these three different quarks. So you find up quark here also, you find 3 up quark here also, but this is just a rearrangement. But what happens, these two get combined with each other, because this is a quark and anti-quark. So quark and anti-quark can do an annihilation as a electron and positron do. And when they do the annihilation, they generate a gluon. They generate a gluon. And this gluon can again decay into a different kind of flavor of quark and anti-quark. तो एक up और दूसरा anti-up. So this is what is happening here. So a gluon is being generated, and that has, it is not so simple. Actually, not only one gluon has done the things. Even they can also exchange the gluon while doing change from U to U again. तो बीच में वो क्या करेगा, change कैसे करेगा, and it can do the it can exchange. This is very simple if you write in the terms of flavor. हमने सारा reaction किसमें, फ्लेवर के फॉर्म में लिखा, हमने कोई भी कलर यहाँ पे कोई रेड ब्लू ग्रीन मैंने मार्क नहीं किया है. तो वी आर जस्ट राइटिंग इन टर्म्स ऑफ फ्लेवर. तो फ्लेवर के सेंस में किसी भी रिएक्शन को लिखना, इट इज वेरी सिंपल. It is very simple. You can do for many different kind of reactions. और सब में चेक करो कि भी क्वार्क कॉम्बिनेशन क्या है और फिर उधर क्वार्क कॉम्बिनेशन क्या है. और जब भी कोई क्वार्क और एंटी क्वार्क का आपको कॉम्बिनेशन मिलता है, तो दे कैन ऑलवेज डू द एनिलेशन एंड दे कैन अगेन प्रोड्यूस अ particle, and that particle will be also a quark and anti-quark. Let me write one more reaction. Just book से मैं दिखाता हूँ how the color is exchanged. अभी तो हमने color का discussion ही किया. For example, if you have an interaction between, we will write in the Feynman diagram form, which is more relatable in the this interaction. So I just write, this is your U, and this is of red color, and that become a U after interaction. It become a U of blue color, and it has interacted with uh, another D, which is a blue color. This is blue actually. And after interaction, this D become a red color. Okay. So if only this is given to you, that there is interaction between these two, and this become this one and this become this one. So there is an exchange of color. क्या हुआ, U आपका जो पहले रेड था वो ब्लू हो गया, यानी इसका ब्लू कलर का charge it has took from this D, and this U has took, and similarly this R has been transferred to this particular D. So there is an exchange of gluon. And what kind of gluon that would be? क्या हो सकता है? This red has been given to the D. This red color has been given to the D. So red is removed. So this UR is removing the red color from itself. So it is giving a red color, means it is passing the red color to the D. But it become a blue. When it is passing a red, it become a blue. So what could happen? Means the gluon is exchanged from here to here. What I'm writing is the gluon has been thrown from U to D, and it has done this kind of interaction. So क्या लिख सकते हैं? Means when it is throwing, what could happen? What could be the other possibility? क्या हो सकता है यहाँ पे? मैं क्या लिख सकता हूँ? Imagine करो, this has given the red color. There was already a blue color, and we are left with only red color. So I have to provide anti-blue. So this blue and anti-blue should become colorless, and this red is only existing. So we are throwing this, means U is throwing this kind of particle to this particular D, and how this red has been means how this red has become red for this particular D, which is initially a blue color D. And this negative blue, when it is being thrown from the U, means when it is generating this red and blue anti-blue kind of gluon, then red must be having a blue color. रेड के पास तो ब्लू पहले से नहीं था ना, इट वाज नॉट अ ब्लू कलर. So when it is generating anti-blue, so it has to become a blue color. How this reaction you have to write in terms of quark. So let me just write the same reaction, or we will see from the book the same reaction, and the same reaction in terms of gluon exchange. This is only in terms of what we are saying in the flavor kind of thing, and this is what you are discussing in terms of flavor plus the color also. And this is a very simple interaction which we are discussing, and this is a very complicated interaction. फ्लेवर में तो बहुत सिंपल दिख रहा है, but जब color इसमें introduce कर दोगे तो it will be a very different thing. Once we will see this reaction, then we will discuss certain reaction and decay, what are the things which is conserved or not conserved in according to the quark model. तो एक बार जब reaction हम check कर लेते हैं, उसके बाद उस reaction को एक बार देख लेते हैं, then we will discuss. And what I'm saying, it is very complicated, so it is actually a complicated. You cannot write the color interaction or color kind of thing. एक reaction के लिए लिखने के लिए आपको बहुत time चाहिए. So let me just share you the crane which we have the teams also. Okay. See this reaction. This is what I have written. And this is another reaction. This is also possible that these two D can combine and they can become UU bar, which is what I have written, and it can become SS bar also. This is strange and strange. So this become a new particle. So this is just a rearrangement. But if you see in terms of gluon exchange, then this is the reaction. This U and this is another U and this is another D. So here I started with UUD and this is D bar and U. These are the different gluon which is being exchanged and finally you are getting this particle. For example, I just show you here this D which is of green color. They have also marked here. So that is only the blank bar is green color. So it has given the green color to this up quark and it become this one slant line kahan pe ye wala blue. So when it is becoming blue, it is emitting the blue bar also, means anti-blue. So it has to give the green and anti-blue so that it become a blue. So any quark, if it is giving its color and anti-color, so it become a color of that anti-color. So I will write that reaction in the that. Let me write here only. If yes, have the choice here also. Let me write. For example, if we are having any quark and say if it is of red color and it emits a gluon which is of red color and a green anti. Obviously red है तो red color को तो emit करेगा, तो दूसरा उसके पास जो होगा वो anti color ही होगा, यानी या तो blue anti हो सकता है, red anti हो सकता है, या you can have a green anti. So whenever it is doing this kind of reaction, it will become a quark with a green color. This is what you have to remember कि जब भी वो emit करेगा अपने कलर का एक क्वांटिटी और एक एंटी करेगा तो इट विल बिकम दैट कलर, सो इट विल बिकम ग्रीन. सो दिस इज व्हाट यू आर सीइंग. सो इट इज एमिटिंग अ ग्रीन blue bar. Bar ठीक से नहीं दिख रहा है, but this is blue bar. This is what they have here, it is written. So when it is emitting, so this become this one, this D, पहले D आपका क्या था, green color का था, now this D is blue color. But this U which has consumed which has actually took this particular glue on, so this U was in this is actually a green color है ना, ये ग्रीन ही हुआ ना, ये वाला और कोई कलर तो नहीं है एक्चुअली, इसमें पिक्चर भी
Blue.
ठीक दिख रहा है. अच्छा ब्लू है, दिस इज ब्लू, this is blue. So blue and anti-blue will become zero, means that is colorless, and you are left with only U green. So this U, which was very in writing in flavor only, this u become u. हम सिर्फ इतना ही लिख रहे हैं. But this u actually first it was u blue, then u green, then you have u, what you can call it as, it has emitted it has given, or it has uh, emitted a green and red bar, so this become a red. Yes, this is red. When this is red, this has consumed another particle which is actually red, it has anti-red and green, so again it become a green. And finally here you are reaching with this kind of bar, so this is red. If I'm correct, this is red. Yes, this one. So because anti-red है, जो emit कर रहा है, तो ये red बन जाएगा, और blue आपके पास पहले से ही था, this is blue, so this is U. So this is not so simple. The U become U. It is very simple to say in terms of flavor, but in terms of gluon, they are constantly they are being exchanged between the different. That is why they are intact in a very small dimension. Because when you are looking at the particle, बाहर से तुम्हें क्या दिख रहा है कि उसके अंदर एक आपके पास different color के quark हैं और different flavor के quark हैं. But it is not so easy because gluon has to be exchanged continuously. Otherwise they don't have the interaction. वो तो फिर free particle हो जाएंगे. तो always there are so many gluons at any time. So when you look at the particle, you are looking at these gluons also. But obviously these are massless particles. They don't carry any mass. So we don't measure them easily. Obviously when it is being exchanged, if it is exchanged and you can see yes, flavor is changing, something is changing, then you can interpret yes, gluon was there. But every time, और मेरे ख्याल से पिछले लेक्चर में मैंने बोला था सिर्फ gluons ही नहीं होते हैं, there are combination of anti color also. Means there are so many possibility of these different kind of quark which can be quark and anti quark combination. तो gluons तो हैं ही, but quark and anti quark combination भी बहुत सारे हैं इस particular particle में. Then only it is doing an interaction and they are getting intact within such a small dimension. अगर gluon exchange ही नहीं होंगे तो they are just free particles. So they can be free, which is not possible. The quark is not existing as a free particle. So this is how the reaction. This is what we have discussed only for this U. You can discuss for this U also. You can discuss how this D also they are getting annihilated. How they are getting annihilated. This is what color? This is blue. And what about this one? This is actually it is giving a blue and green. So what is this one? This is actually a blue anti. This is D blue anti. So when D blue and D blue they mix up and they become just a you can say they just annihilated each other. And after some time, now they become a new particle, which is again it is same kind of line. So this is S blue, and you can say this is S. What is this one? This is anti-blue. Obviously, if it is blue, so this is anti-blue and blue, and they become normal, which is S green, and this is S. You can say it is green, which is actually anti. So this is a S and this is anti-S particle. So this is what you are doing. ये मतलब इसके साथ ग्रीन है तो ये obviously green और anti green है तो ये anti quark हो गया. कोई anti color आएगा तो it is anti quark. So this is how we write, but exam में ये लिखने के लिए नहीं आएगा. Exam में जो आएगा वो ये वाला लिखने के लिए आएगा. This is simple to write and we can see different interactions, and book में आपको example भी बहुत मिल जाएंगे. This is a annihilation. Positron always drawn in opposite direction. Electron is always drawn in a forward in time and space. And positron is always backward in time. ये मैंने पहले भी जब Feynman diagram में starting में बोला होगा. तो जब भी anti particle होते हैं, you have to make it in a backward in time. They travel backward in time. Just to have a understanding कि we are something like a nomenclature for the antiparticle. So what electron and positron, if they annihilate and if they become a photon, these photon can also generate quark. That is a possibility. So there is a possibility that this can become a U and D bar and D and U bar. So this is a rearrangement. U or U bar भी बना है, means this is what the line is saying, that it's become a U and U bar, and within this range there is a possibility. This is for certain time when you have these two particle and there is another particle. For certain time you can say this is a rho naught particle. So rho naught is not a single particle, it is a resonance of a certain combination of quark and photons. So this is something like a combination kind of a state. So it is not so easy to understand. It is something like resonance. and after that it become pi plus and pi minus. So you can write every reaction in terms of these different. And there is another reaction which is phi particle, phi, which is s and s bar. It emitted a three gluons, and all these gluons are generating and converting into quark and antiquark, quark and antiquark, and this is again a quark. So we become these kind of particles. So every reaction has to be consistent with the color charge of the quark. It has to be consistent. अगर वो consistent नहीं हो रहा है, किसी भी reason से आपको लग रहा है कि ये reaction possible नहीं है, so you can easily say कि yes, this reaction is not allowed. Okay, so this is what in terms of quark, but you can always write in terms of this the quantum number which we have already discussed. So I will discuss one or two reactions according to those quantum numbers which we have discussed, as for example baryon number, lepton number, isospin, and strangeness number. We will discuss that in the next class, that is your tutorial class. Tutorial class में एक आधा questions करेंगे और उसके बाद फिर जिन बच्चों का presentation है they can start with the presentation. And I have to give you something more about three statement about the uh, reactions and decay in terms of quark model. So just join the tutorial class. एक बार tutorial class में join कर लो. हाँ बोलो बोलो. Yes.
सर ये जो
Yes.
क्वार्क और एंटी क्वार्क के बीच में कर्व है, ये इसका क्या मीनिंग है? इंटरेक्ट कर रहे हैं?
कर्व मतलब कहाँ कर्व, कौन सा, ये जो स्प्रिंग वाले कर्व है ये, दिस कर्व और विच कर्व यू आर सेइंग?
सर यू शेप्ड कर्व है क्वार्क और एंटी क्वार्क के बीच में.
ये तो ये एनिलेशन शो कर रहा है, मींस दे आर गेटिंग कंबाइंड विद ईच अदर. ये जो कह रहे हो ये वाला ना, दिस वन.
यस सर.
This one, something like this one you are saying na. So this is actually, if you if you draw like this one, it means from nowhere these two has been generated, and it is always possible. From vacuum they can be generated. You can generate these particles, and after their generation there is a possibility that they can recombine also. But if you find certain other particles with this or with that particular particle, it form a certain different kind of state, then they can exist as a particle. तो यहाँ पे क्या हो रहा है, ये आपका फोटोन है, ये फोटोन आपका ये दो डिफरेंट क्वार्क और एंटी क्वार्क पेयर में जनरेट हो गया, दैट इज यू एंड यू बार. ठीक है. when they are generated, within that particular instant also there is a generation of this d and t bar also. ये इससे नहीं आया, ये तो u और u बार जनरेट हो गए, बट देयर इज अ चांस कि दैट दिस d एंड d बार कैन आल्सो जनरेट. मींस ये बनाने का मतलब ये है कि ये जनरेट हो रहे हैं फ्रॉम नोवेयर. एंड ऑब्वियसली व्हेन यू आर हैविंग अ वेरी हाई पोटेंशियल सिस्टम और एटम न्यूक्लियस के अंदर यू हैव अ वेरी गुड अमाउंट ऑफ पोटेंशियल, एंड दीस पार्टिकल आर जस्ट पॉपिंग अप. And popping up means they are generated, but they will always generate in the form of pair. Means if you have a photon, you can generate what, a positron and electron. So you need a photon. But quark को generate करने के लिए क्या चाहिए? Gluons. And we know in system or in nucleus or within the even the neutron and proton, there are so many gluons are always being exchanged. तो कई बार होता है जो gluon exchange हो रहा है, वो gluon exchange होने से पहले क्या करता है? It divide into two different quark. So they can easily be generated. There is no limitation कि भाई हमें तीन ही gluon बनाने हैं कि 10 gluon बनाने हैं. We don't know. That can be whatever number you can think. और जितने ज्यादा नंबर आप सोचोगे कि इसके अंदर आपके पास gluon है और आपके पास quark एंटी quark के पेयर हैं, because these pairs are generated from these gluons, and these pair again annihilate themselves and generate a gluons. This is what goes on happening. This is what goes on happening. That is why the only we are able to measure 1% of mass of the system. बाकी जो 99% मास है ना, वो तो हम मेजर कर ही नहीं पा रहे, because they are so many and they are just don't express themselves. They are just like behaving as a virtual particle. तो एक एवरेज फॉर्म में we only get the mass of these three different quarks which is existing. रेस्ट तो हमारे पास जनरेट हो रहे हैं, डिके हो रहे हैं, जनरेट हो रहे हैं. देयर इज नो लाइफ टाइम एक्चुअली. These reactions are happening in how much? 10 to the power of minus 23 seconds. ठीक है. फॉर एग्जाम्पल इफ आई से कि सर आपने बोला कि -23 सेकेंड्स, वो हो कैसे सकता है, हाउ इट इज पॉसिबल. You can easily calculate that number also. Very simple way of calculation. Why we are saying this strong interaction is so it takes so much of less time. Why we are saying this statement, and you can check that. What I have said you, that proton is having a size of how much? 0.8 Fermi, roughly, which is you can imagine. Let us imagine 1 Fermi. ठीक है, तो 0.9 के आसपास है. तो लेट अस इमेजिन कि आपका प्रोटॉन का जो साइज है 1 Fermi है. ठीक है. ओके, इज इट ओके?
और सर ये कलर एक्सचेंज किस बेसिस पर हो रहा है, या रैंडम है जो हमने एक्सपेरिमेंटली वेरीफाई की है?
यस. फॉर एग्जाम्पल देखो, अब ये ऊपर वाले एग्जाम्पल देखते हैं. ये दो रिएक्शंस हैं, दोनों के इनिशियल प्रोडक्ट सेम है. दोनों के इनिशियल प्रोडक्ट सेम है
यस सर.
एंड आउटकम इज डिफरेंट. आउटकम इज डिफरेंट. अगर मैं इनिशियल रिएक्शन कर रहा हूं, अब आउटकम हो सकता है ये 60% चांस हो सकता है ये 40% चांस. Why it is possible ki we are getting these two? Why we are not getting only one kind of thing? Because there is a possibility, because when they have annihilated themselves, then when they become a quark, sorry, when they become a gluon, that gluon can decay into two quark and anti-quark, and there is no restriction कि वो up quark हो या strange quark हो या bottom quark हो या charm हो. There is no restriction. Obviously the energy will be required. For example, u quark आपका 30 गीगा इलेक्ट्रॉन वोल्ट का होता है, एस क्वार्क भी आपके रफली 30 के आसपास होता है. बट बॉटम टॉप और ट्रुथ और एक सेकंड होल्ड करना बेटा. Okay, so there is no restriction that what is going to generate. It only depend upon the energy. अगर उस ग्लूऑन की एनर्जी ज्यादा है तो इट कैन जनरेट अ हेवी जनरेशन, हेवी जनरेशन ऑफ क्वार्क आल्सो. तो अप डाउन क्वार्क के अलावा वो टॉप बॉटम भी जनरेट कर सकता है. तो देयर इज नो रिस्ट्रिक्शन. व्हेन यू सी द रिएक्शन, भी इस रिएक्शन में कौन डिसाइड कर रहा है? कोई डिसाइड ही नहीं कर रहा है कि यहाँ पे क्या हुआ है. It only depend upon the energy, how much energy is there with the gluons. So these two annihilated and the gluon has been generated, and it will also depend what is the energy of these two particles. Means what was the momentum of these particles and what how they have combined. Means when you're bombarding this pi plus on a proton, then what energy you have given to these quark. They don't only have the mass energy, but they have the relativistic energy. Means that is total energy, that is the momentum energy also. That will also decide ki what kind of particle is going to generate. But there is a possibility that you can u bar can be generated or s bar can be generated. Out product out is different. Out product आपको जो मिल रहा है ना, जो आपका product मिल रहा है after the reaction, that can be a different number, that can be a different particle. And we have seen these particles कि कई बार रिएक्शन होता है तो ये पार्टिकल भी जनरेट हो रहे हैं, हो सकता है 60% जनरेट हो रहे हैं और ये पार्टिकल आपके 40% जनरेट हो. But you have to explain why they are being generated, because there is a possibility that this u and u bar has become as a after this decay of the gluon, or sometimes you can say that s and s bar has become a possibility after the decay of the same gluon. So that is a possible. That is not. अब फोटोन के केस में सिर्फ हमारे पास दो ही है. फोटोन के केस में क्या है, वी ओनली हैव प्लस चार्ज एंड माइनस चार्ज. तो जब भी जनरेट होगा तो आपके पास एक इलेक्ट्रॉन और पॉजिट्रॉन ही जनरेट होगा. अगर चार्ज की भी डिफरेंट डिफरेंट पॉसिबिलिटीज होती तो एक फोटोन कैन जनरेट डिफरेंट काइंड ऑफ पार्टिकल. इज इट क्लियर?
यस सर.
ठीक है. तो हमारे पास देखो रिएक्टेंट सेम है दोनों केसेस में, बट प्रोडक्ट आर डिफरेंट. व्हाई द प्रोडक्ट आर डिफरेंट? बिकॉज एक बार उसने एस एस बार जनरेट किया, एक बार उसने यू एन यू बार जनरेट किया. That's all. This is what, and that will depend upon the energy calculation. How much energy is having with the initial particles, that will decide. कि वो आपने कैसा ग्लूऑन जनरेट किया। और ये तो सिर्फ उस फॉर्म में, व्हेन यू डिस्कसिंग इन द this particular color form, then the gluon are exchanged continuously. There is no restriction. You cannot, अब यहाँ यहीं पे चेक करो, 1 2 3 4 5 6 7 8, roughly 8 gluons has been exchanged what we are writing, but there is no restriction. You can make hundreds of gluon, you can make millions of gluon. It is your calculation how much you are, how much gluons you put, how much virtual particle you put, that will give you the better result if you do the calculation. This is what quantum chromodynamics say. जैसे क्वांटम इलेक्ट्रोडायनेमिक्स था ना, विच इज कंसर्न विद द चार्ज, इसी तरीके से यहाँ पे हम डिफाइन करते हैं क्वांटम क्रोमोडायनेमिक्स। क्रोमो मींस कलर, सो दैट इज क्वांटम कलर डायनेमिक्स यू कैन से। और कलर वर्ड अच्छा नहीं लगता है, तो इट इज बेटर टू से ना क्वांटम क्रोमोडायनेमिक्स, दैट इज कंसर्न विद द क्वार्क इंटरैक्शन। तो जितने आप ज्यादा वर्चुअल पार्टिकल बना सकते हो उतने बनाओ, उसकी कैलकुलेशन करो, यू विल गेट द बेस्ट रिजल्ट। If you make 1 or 2 virtual particle, you will get the not the best result, you will get the result, but that is not so accurate. तो सबसे बेस्ट जो थ्योरी है जो प्रिडिक्शंस करता है, दैट इज क्वांटम क्रोमोडायनेमिक्स और क्वांटम इलेक्ट्रोडायनेमिक्स। ठीक है, इज इट ओके?
यस सर।
ओके, सो यहीं पे मैं स्टेटमेंट भी आपको, तीनों जो इस स्टेटमेंट है, when you are discussing the reaction and decay for the Quark model, then we will join the tutorial class. So the first thing that we have to remember, strong interaction whenever the okay, this what I was saying, मैं यहाँ पे रुक गया था. Why these strong interaction occurs at such a small amount of time? Strong interaction किसके बीच में हो रहा है? प्रोटॉन प्रोटॉन के बीच में नहीं हो रहा है, न्यूट्रॉन न्यूट्रॉन के बीच में नहीं हो रहा है, प्रोटॉन न्यूट्रॉन के बीच में नहीं हो रहा है. It is actually happening between the quark within the proton and the quark within the neutron. ठीक है, वो कहाँ हो रहा है? क्वार्क के बीच में एक्सचेंज हो रहा है. क्योंकि अगर प्रोटॉन के बीच में अगर डिस्कस करते हैं तो दैट इज नॉट अ परफेक्ट वे, बिकॉज दैट इज नॉट you can say the elementary interaction is happening because it is a composite particle, and pi is being exchanged, that is also a composite particle. So rather than what we have to discuss is the exchange of gluon is actually the strong interaction. The same exchange of gluon is actually the strong interaction. So why it is of such a small amount of time? तो इंट्रैक्शन होने का मीनिंग क्या है? इफ ग्लूऑन इज बीइंग एमिटेड and it has to be absorbed by the another particle which is also quark, and it has been emitted by a quark. तो दो क्वार्क हैं, दोनों के बीच में ग्लूऑन एक्सचेंज हो रहे हैं, और जब एक्सचेंज हो रहा है तो पार्टिकल इंटरेक्शन हम तभी जस्टिफाई करते हैं इफ इट इज बीइंग जनरेटेड एंड इफ इट इज बीइंग एब्सॉर्ब. अगर वो वैनिश हो गए बीच में, देन दिस इज नॉट अ इंटरेक्शन. सो व्हाट इज द डिस्टेंस दैट quark sorry a gluon can travel, because they are they are massless particles, so they will travel with speed of light. उनका जो स्पीड होगा वो लाइट का स्पीड होगा, तो उसका स्पीड आप 3 into 10 पर 8 मीटर पर सेकंड लेके चल सकते हो, because they are massless particle, they are generated from nowhere, and when they are being thrown by the quark, the quark does not lose its mass, so they are massless particle. Okay, so what is the distance which they can travel, and how much time actually they are taking traveling from one boundary of means from one boundary to boundary within a proton? This is what you can say. So within a proton, if it is traveling across the diameter from one boundary to other boundary, if it is traveling, how much time it will take? If its speed is 3 into 10 to the 8 meters per second, which is the maximum possible speed, and the distance we know which it has to travel is 1 Fermi. तो डिस्टेंस आपको पता है, आपको स्पीड पता है, तो यू कैन इजीली कैलकुलेट हाउ मच टाइम इज रिक्वायर्ड टू कैच अप दिस ग्लूऑन्स. अगर उसको आप कैच अप नहीं कर पाए तो आपने इंटरेक्शन नहीं किया. इंटरेक्शन करने के लिए उसको आपको कैच करना है. तो यू कैन इजीली कैलकुलेट दैट द नंबर कम्स आउट टू बी 10 to the power of -22 or -23 seconds. So this is the possible time. Within this time you have to catch up a gluon. इससे ज्यादा टाइम लगो तो ग्लूऑन आपका मिस हो गया. So that is why the strong interaction occurs in such a small time, because these gluons are generated and they have to be catched up. And what is the allowed distance? Allowed distance is 1 Fermi. एंड 1 फॉर्म ही है, और उसका जो स्पीड है ग्लूऑन का वो 3 × 10⁸ है. जस्ट कंबाइन दीज टू नंबर्स, you know very well कि how much time will be required. So this is what we are getting this time. हम सिर्फ ऐसी फैंसी नहीं कह देते कि बस ये टाइम लगता है, but this is the time and you can easily calculate that. So the reaction and decay in terms of quark model. Strong interaction cannot change the flavor of quark. This is what very important. Only rearrangement of quarks among the particle can occur. Strong interaction does not change the flavor of quark. Color की बात नहीं हो रही, flavor. Color can change, but the flavor of quark. Second, quark and anti-quark pair can be created or can be annihilated exactly as a positron and electron do in the electromagnetic interaction. तो क्वार्क और एंटी क्वार्क पेयर जनरेट भी होते रहते हैं और एनिलेट भी होते रहते हैं. थर्ड वन, वीक इंटरेक्शन कैन चेंज द फ्लेवर ऑफ क्वार्क. वीक इंटरेक्शन हमने कहां देखा था? बीटा डी के. न्यूट्रॉन बिकम प्रोटॉन और प्रोटॉन बिकम न्यूट्रॉन. This is happening only when one U is becoming a D or one D is becoming a U. तो D और अप क्वार्क का क्या चेंज हो रहा है? फ्लेवर चेंज. अगर D आपका U बन गया है तो फ्लेवर चेंज हो रहा है. तो वीक इंटरेक्शन कैन चेंज द फ्लेवर ऑफ क्वार्क. तो जब भी वीक इंटरेक्शन होगा, the flavor is going to change. For example, this is, let me write here only. I just write here. Strong interaction does not change the flavor. Quark and anti-quark can combine, means can be created or can be annihilated. And third is weak interaction can change the flavor. So what are the reactions? So you can do a weak interaction, it become D by emitting a W boson. W boson, we have already discussed weak interaction के 3 bosons हैं, W plus minus and Z. And S can become U when it is emitting a W minus. U bar can become D bar. Again a flavor is changing. दोनों एंटी क्वार्क हैं but flavor change हो गया है. It can emit a W minus. Similarly, S bar can give rise to U bar and emitting a W plus. And these W plus, W minus is again further going to decay. They are going to do the decay. And the third one, which is Z, you can say, or we will write first the reaction for this one. S become D when it is emitting a Z. So Z boson. And Z boson can become U plus U bar. It can become D plus D bar. Sorry, D bar. It can become S plus S bar. तो Z बोसॉन की पॉसिबिलिटी है कि तीनों डिफरेंट क्वार्क एंटी क्वार्क को फ्लेवर के क्वार्क को जनरेट कर सकता है, बट W कैन नॉट डू दैट. W के लिए हमारे पास रेस्ट्रिक्शन, बिकॉज दे आर चार्ज पार्टिकल. अनचार्ज है वो तो ये तीनों को जनरेट कर सकते हैं, लेकिन चार्ज पार्टिकल आपके चार्ज पे ही डिपेंड करेगा. अभी भी मैंने क्वार्क का आपको वो नहीं दिया है, ऑल द 6 क्वार्क एंड देयर प्रॉपर्टीज, मींस वी विल डिस्कस, वी हैव द क्लास, तो उसमें हम डिस्कस करेंगे डिफरेंट क्या प्रॉपर्टीज है आपके क्वार्क का, क्योंकि कई बार टेबल बनाने को आता है. You have to write all the 6 quark, their antiparticle, their spin, their charge, their quantum numbers, so that you have to write. तो ये मीटिंग हम एंड करते हैं. पहले हम 10 मिनट ऊपर चले गए हैं. Let me just end the meeting and I just start the tutorial. और ट्यूटोरियल में जिन बच्चों का वाइवा है वो आ जाएं, और क्वेश्चन पेपर एक है, तो आई विल जस्ट डिस्कस द क्वेश्चंस. इफ यू नो द आंसर्स देन इट्स ओके. हाँ बोलो.
तो वर्ड फाइल शेयर कर दो,
वर्ड फाइल एक
जिस पे
सेकंड.
आपने स्टार्टिंग में लिखा है.
हाँ मैं शेयर कर रहा हूँ. ये मैं आपको पूरा नोट में दूंगा, मैं अपलोड करूंगा. ये है वर्ड फाइल. यू आर नोटिंग डाउन समथिंग? आप नोट
तो
डाउन कर रहे हो
दूसरा
क्या?
शेयर,
नहीं,
फाइल
यही वाला
शेयर.
पेज था. वो पीडीएफ था जो मैंने बुक का शेयर किया, तो पीडीएफ था. वर्ड फाइल में तो सिर्फ इतना ही लिखा था मैंने.
सर
मैं दोबारा
शेयर
शेयर कर देता
मतलब
हूँ।
जैसे चैट बॉक्स में शेयर
अच्छा
करते
वो
हैं।
वाला, वो तो मैंने उसमें लिखा था पीडीएफ में, मैं वो रुको, अ, अभी उसमें ज्वाइन कर लो, मैं दोबारा लिख के देता हूँ आपको, ठीक है।
सर यही
आप
फाइल है।
ट्यूटोरियल, हाँ क्या क्या कह रहे हो?
सर ये वाली फाइल जिसे आपने लिखा है रेड पेन से।
हाँ ये तो मैं शेयर कर ही रहा हूँ, ये तो मैं आपको शेयर कर ही रहा हूँ, ये रहा, ये सारा ये यही चाहिए आपको। ये मैं कॉपी में लिख करके नोट्स बना करके आपको दूंगा, उसकी टेंशन मत लो।
यस सर।
वहां पे मैं दे दूंगा आपको अबाउट दीज डिफरेंट डिफरेंट जो भी है। मेन पार्टिकल फिजिक्स का एक टॉपिक और रह गया इंटरेक्शन वाला, वो मैं करके आपको दे दूंगा, बाकी मैंने पहले के 2 यूनिट मैंने दे दिए हैं। तो इंटरेक्शन वाला मैं ये पार्टिकल फिजिक्स वाला पहले दे दूंगा आपको, ताकि इजीली आप समझ पाओ। क्रेन मैंने क्लोज कर दिया एक्चुअली, नहीं क्रेन मैंने ओपन रखा है, यस क्रेन इज ओपन हियर, तो लेट मी शेयर दैट आल्सो। ये लो, जिसको नोट करना है। क्रेन ओपन क्यों नहीं हुआ है तो ओपन ये, आपको यहाँ पे खुल रहा है, ये देखो क्रेन शेयर नहीं हो रहा दोबारा। ये तो मेरे जो बुक्स की फोल्डर है वो शेयर हो रही है आपको, तो नहीं कहाँ चला गया वो। लेट मी शेयर द स्क्रीन ओनली। ये लो, ये कह रहे थे ना।
यस सर।
ये है, और ऊपर वाला मैंने ये लिखा था बस, और ऊपर क्या था और नहीं था। दिस वन एंड दिस इज व्हाट, दीज आर एक्चुअली द फ्लेवर इज चेंजिंग। जब वीक इंटरेक्शन होगा तो क्वार्क के फ्लेवर चेंज हो रहे हैं, जब स्ट्रॉन्ग इंटरेक्शन है तो फ्लेवर चेंज नहीं होगा। कलर कैन चेंज because color is always being exchanged between the quark, and that is actually the strong interaction. वीक इंटरेक्शन में फ्लेवर चेंज होगा, स्ट्रॉन्ग इंटरेक्शन में फ्लेवर चेंज नहीं होगा, और quark and anti-quark can annihilate themselves and they can be created. तो ट्यूट क्लास स्टार्ट करें, जिन बच्चों को वेट करना है वहां पे वेट करके आ जाएंगे वो। बंद कर दूं अब मैं? ओके, आई जस्ट एंड दिस मीटिंग, एंड ट्यूट क्लास में जिन बच्चों का वाइवा है दे कैन कम देयर।